Okay, theta notation. So what is theta notation? So if a bigger notation is like this, in your mind, what is it you are thinking? So when you have a bigger notation like this, in your mind it is something like the form f of n is less than or equal to g of f, right? This is what you have in your mind. I mean, exact thing will be there's a constancy and n is greater than from n naught, n zero, right? But in your mind, you can view you're viewing it as f of n is less than or equal to g of n, right? Now, same thing, I would also want to have a similar kind of view for f of n is equal to g of n. This is what I am interested in. The same similar view. And how is that going to be? And so that is what theta notation is trying to capture. So it's trying to capture that two algorithms are same, have the same running time. It might differ in some constants, but fundamentally they are the same. Okay, or it might be different in the beginning of the run, but after some time it's going to be the same. So I want to capture that. Bigger notation captured the fact that one algorithm, our algorithm can be upper bounded by a function, right? So this is an f of n is upper bounded by g of n, and in some sense, but this upper bound comes into effect after some constant n0, and the upper bound is by a constant times that function g of n. So that is what O of n was. And now I want not an upper bound; it's kind of an exact bound is what I'm interested in. So let me define the theta notation now. So we say that f of n is equal to theta times g of n if we say that f of n is equal to theta of g of n if f of n is equal to big O of g of n and g of n is equal to big O of f of n. You see, it's both sides. I'm talking about both sides. F of n is equal to big O of g of n and g of n is equal to big O of f of n, right? So what is it I'm trying to say? This is saying that, so what does the first one say? First equation says that f of n is less than or equal to c times g of n after some point, and this says that g of n is less than another constant. So let me call it d times g of n. Okay, so where c and d are constant. So if I have to write the theta notation like this, what will I write? I will have to write, if there exists constant c, d, m0 and m0 greater than 1, such that for all n greater than m0, t of n is less than or equal to c times f of n, and right. This is what, in other words, this means, so other words, it means t of n is equal to O of f of n, and f of n is equal to O of t of n. Okay. Right. Now let's look at a few examples of. So I mean, it's now for you. It's clear, right? How if I give you two functions, how to show that whether they are theta of n or not. You have to show that it is O of n on one side, and you have to show that it's O of n on the other side, right? Let's look at a few examples to see some theta of n functions, some functions which are kind of equal. So I claim the following. So let's say f of n is equal to n plus 1 square. So I claim the following, that f of n is equal to theta of n square. Why? How will you prove that? It's proof. Okay, the proof of this. From where does it proof come? Okay, you have to show both sides. That's our understanding. You have to show both sides. So you have to show that f of n is less than or equal to c times n square for c comma n0 for all n greater than or equal to n0, where c and n0 are greater than or equal to a constant. Where constant c and n0 are greater than or equal to 1. So you have to show something like this. Is this easy? This is easy, right? You pick c to be 4 and n not to be 1. What happens? You have n plus 1 square is equal to n square plus 2n plus 1. This is less than or equal to 3n square. Right, so I could have even taken this to be 3. Okay, so therefore we are done. Right, so we have now the claim that f of n is less than or equal to c. Right. Now what is it I have to show? I have to show the other direction. So I have shown this direction. Now let's go and show the other direction. We can use this space. What is it we have to show? We have to show that n square is less than or equal to c times n plus 1 square. Is this true? This is true for just take c to be 1. Take c equal to 1. Then n square is less than or equal to n square plus 2n plus 1, right? This is true for all n0. This is true for all, right? N greater than or equal to 1. So we have proved that this direction is also easy to see. N square is less than or equal to c times n plus 1 square. So this implies that f of n is equal to theta n square. Okay, so this is kind of an equality. Can you show is this true? Let me write this. I'm going to show this is equal to theta n cube. Is this true? This is going to fail. Where is it going to fail? You won't be able to show this fact. Okay, this is wrong. Okay, that fact is wrong, and therefore you can't show this. But you can show this is big O of n cube. N plus 1 square is big O of n square n cube. You can show this, we saw it earlier, but you can prove the other direction. That's the and you know this reason. This is kind of close to n square, and this is like n cube. This is much bigger polynomial. Right. So the kind of thing in your mind, you can keep this fact that theta means these two functions are kind of close. Okay. Let's go back to n square. This n plus 1 square and n square are close to each other. They are very close functions. On the other hand, O means that it's a bigger function. It may be equal or it can be bigger function. Okay, that's big O notation, and this is theta. The next notation we are interested in is omega notation. We have seen big O notation and we have seen theta notation. So omega notation, interesting. So we say that two functions we say f of n is equal to omega of g of n if f of n is equal to omega of g of n if G of n is equal to big O of f of n. That's all. It's very easy. So what are we trying to say conceptually? Let me try to see. Let me try to say. See, if I write f of n is equal to big O of g of n, what do I see in my mind? I see f of n is less than or equal to g of n. Right? This is what we see. Now, what happens if I have f of n is equal to theta of g of n? What do I see? I see it as. Okay. So this is not exactly. To clarify, this is not exactly less than or equal to or equal to. This is kind of. You know this definition. What I am trying to say. Now comes the. Okay. So if f of n is equal to theta of n, theta of g of n, we view it as f of n is equal to g of n. On the other hand, finally, if f of n is equal to omega of g of n, so this is less than or equal to, and therefore what should this be? Okay, this is what we are going to see. So this is again kind of our notion of greater than or equal to g of n. So if f of n is greater than or equal to g of n, what is that? That means g of n is less than or equal to f of n, right? This implies g of n is less than or equal to f of n. Or right? Or g of n is equal to big O of f of n. So that's what why I said that if we say f of n is equal to omega of g of n, if g of n is equal to big O of f of n, it's clear. It's basically the other way around. So here I have written the definition using the constant CM and so what how let's just quickly go through it. T of n is equal to omega of f of n if there exists constant c and n0 greater than or equal to 1 such that for all n greater than or equal to n0, f of n is less than or equal to c times t of n. Okay. Right. Now let's look at a few examples. And so let's say t of n is equal to, so let's say n cube plus n square, right? And then I can write t of n is equal to, this is 2. And how do I argue that? What is the proof? Proof is, so to prove this, we just argue that we have to argue this fact. N square is equal to big O of n cube plus n square. And this we know that you know how to do this, right? Okay. Because this is same as order of n cube and n square is equal to O of n cube. We solve this fact. Right. What about this? This is also true, right? This is also true because we have to prove that n cube is equal to big O of n cube plus n square, and this is also true because this is equal to O of n cube, and therefore n cube is equal to O of n cube is also true. Okay. So both these things are true. Right. So you can see what is happening, and let's say, let me have something else. Okay. So this is